Welcome back to the deep dive. Today, we've got some specs for a device that, well, it basically acts as a diplomat to the underworld.
That's one way to put it.
We are looking at the NTI E-RTDT1W-1562.
It's a catchy name, isn't it?
Oh, just rolls right off the tongue. But if you look past the alphabet soup here, this is a one-wire transmitter for platinum RTD sensors.
Right.
And the numbers are just, frankly, ridiculous. It says it can monitor temperatures from minus 328 degrees Fahrenheit all the way up to 1562.
It's a massive range, a really massive range.
Massive. That's minus 200 to 850 Celsius. I mean, minus 328 is colder than the surface of Saturn, and 1562 Fahrenheit is hot enough to melt bronze.
Yeah.
So my question is, why do we need a specific transmitter for this? Why not just, plug a thermometer into this system?
Well, because standard electronics would just melt long before you even get close to those numbers. That's the core problem this thing solves. It's a bridge.
A bridge.
Yeah, you have the zone of destruction, that furnace or, that cryo chamber, and then you have your nice, safe monitoring room. This little box stands in the middle.
So it translates the chaos into clean data.
In a way, yeah. It's designed to pair with a 100-ohm platinum RTD sensor.
RTD being resistance temperature detector.
Exactly. So unlike a standard thermocouple, which uses voltage, an RTD measures how electrical resistance changes with heat. It's a different principle.
And I'm guessing the platinum part isn't just for marketing, to make it sound fancy.
No, it's completely functional. Platinum is incredibly stable and linear across that huge temperature range. Other metals, they get erratic, they get noisy. Platinum doesn't flinch.
Right, and that's where the accuracy comes from. I see it's listed at plus or minus 0.09% of the reading.
It's very precise, but you notice that little note in the specs, right?
I did. It says the system reverts to the sensor's accuracy if the sensor itself isn't as good.
That's it, the transmitter. The box, it won't lie to you. It creates a digital picture of the resistance it's seeing. So if you connect a cheap, inaccurate sensor, you're just going to get cheap, inaccurate data.
It doesn't magically clean up a bad signal.
Nope. It just faithfully transports it.
Okay, speaking of transport, let's talk about the connections. The sheet mentions a 4-wire connection for the sensor, but then a 1-wire protocol for the output. Why the difference?
That's the really clever part. The 4-wire connection to the sensor is all about precision.
Okay.
When you're measuring changes in resistance that are microscopic, the resistance of the wire itself can actually throw off your reading. The 4 wires allow the device to measure and then cancel out the wire's own resistance.
So it filters out the noise of the journey so you only see the destination?
That's a great way to put it, yeah. And then once it has that pure, clean reading, it packetizes it and sends it out using the 1-wire protocol.
Which is just for efficiency.
Right. Easy cabling, low complexity for the guys in the server room.
Okay, but I think I found a contradiction here that worries me a bit. It measures up to 1,562 degrees. But then I scroll down to operating temperature, and it says the unit itself basically dies if it gets hotter than 185 degrees Fahrenheit.
You caught that. A lot of people miss it.
So, did they just mess up the labeling?
No, and this is where people can get into real trouble. That 1562 figure is what the sensor can touch. The transmitter, the plastic box with the circuit board inside, that has to stay in the safe zone.
They're like the pilot flying the drone.
Exactly. The pilot doesn't go into the volcano.
So if you mount this little box on the wall of the furnace itself,
you're going to have a very bad day. You're going to have a puddle of plastic and be out about $195.
Which, to be fair, for industrial gear isn't a terrible price point.
Not at all. It's very accessible. And you should also note the TAA compliance.
Trade Agreements Act.
That's the one. It means the supply chain is vetted. It's usually a requirement for U.S. government contracts, things like that. It tells you this isn't just some generic hardware.
Okay, so let's zoom out. We have a small gray box about 4 inches wide. It sits quietly on a wall, connected to a platinum wire that snakes into an environment that would kill a person instantly.
And it turns all that danger into a simple number on a screen. It's about visibility. Without these little translators, industrial chemistry, metalworking, cryogenics, it would all just be guesswork.
It effectively tames the environment for us.
It definitely keeps the engines from melting down, let's put it that way.
It really makes you think about the layers of infrastructure we just completely ignore. We walk past factories and labs and hospitals every day, totally oblivious to these constant invisible data streams that are keeping the extremes at bay. It makes me wonder what other critical measurements are happening within 10 feet of you right now that you have absolutely no clue about. Thanks for listening to The Deep Dive.